All right, we've talked about isotopes, we've talked about mass number, and that the mass number is the protons plus the neutrons, and that is for a particular atom. If we were to look at the whole group of atoms for an element, they might have different masses. So the mass that's on the periodic table is the relative atomic mass. So we have our atomic number, which we should know is our protons. We have our symbol, and then that other number is the average atomic mass. So it's the weighted average of all natural occurring isotopes. So again, the difference between the atomic mass and the mass number is the atomic mass is the weighted average of all the isotopes, and the mass number is for one atom, as opposed to the average of them all. Okay, so to find a weighted average, you multiply the percent by mass for that isotope. So for example, carbon has two isotopes, carbon 12 and carbon 13. The most common isotopes are 12 and 13. So 99% of the time you would get a carbon 12, 1% of the time it might be carbon 13. So you would take that mass and you would multiply it by the percent, so 12 times 99, 13 times 1, add them together, and then divide by 100, because we don't want a percentage. So again, multiply, add each of them together, and then divide by 100. So here we have copper. Copper has two isotopes, copper 63 and copper 65, and it's asking us for the average atomic mass. Well, just by looking, if copper 63 is almost 70%, you would have 70% of a chance pulling copper 63, then the weighted average is probably closer to 63 than it is 65, because you have a more chance of getting that mass of 63 than 65. So it's not 50-50. The average mass is not 64 because we have to take a weighted average, but it's going to be closer to 63 because that isotope has the higher percentage. So we take the mass, 63, we multiply it by the percent, and then we're going to add that to the other isotope, the mass, 65, times the percent. Okay, and that gives us a very large number, and we are going to divide it by 100 because we don't want it to be a percent anymore. And then we're going to give the answer to two decimal places, so 63.62. Now the average atomic mass doesn't really have units, so we can just leave it as 63.62. If you want to give it a unit, you could use the unit AMU, or average or atomic mass unit, if you wanted to, or you can just leave this unitless. There's very few things out there that don't have a unit. This is one of them. Let's look at another example. So strontium consists of 4 isotopes with a mass of 84, 86, 87, and 88. Calculate the atomic mass of strontium. So notice that the mass 88 has the highest percentage. So when we calculate this average mass, it should have an average closer to 88 than 84. So we're going to do the same process. We're going to take our mass and we're going to multiply it by the percent. And we're going to take our mass and multiply it by our percent. Take our mass, multiply it by the percent. Mass times the percent. We're going to add all of them together. we get a large number. We're going to divide that by 100. And we're going to write the answer to 2 decimal places. So 87.71. Now if we look on the periodic table at strontium, which is number 38, this says we have a mass of 87.62. So we're pretty close. The difference is just coming to how things were rounded, how our percents were rounded. But notice that that average mass of 87.71 is closer to 87 than it is the other options. All right, one more example. This one, we're kind of working backwards. So we know that nitrogen is made up of 2 isotopes, nitrogen 14 and nitrogen 15. And together, when we take that average mass, it should have a average weight of 14.007. So we're going to kind of work this backwards. So remember, when we find the average mass, we end up dividing it by 100 to get this average answer. So the first thing that we're going to do is we're going to take that 14.007 and we're going to multiply it by 100. So we get 1400.7. And then we have 2 isotopes. We have isotope 14 and isotope 15. And we would multiply those by their percents. Well, one of them is going to be X. And then we should know that percents always add up to be 100. So if this has a percent of X, then this one would have a percent of 100 minus X. And then we just have to solve for X. So simplifying this, 14X plus, and then I'm going to distribute, so 15 times 100 minus 15X is equal to our 1400.7. I'm going to combine my like terms. So 14 minus 15 is negative 1x plus 1500 equals 1400.7. And then I'm going to subtract by 1500 on both sides. So I have negative 1x is equal to negative 99.3. And then if I divide by negative 1, x would equal 99.3. So that tells me that N14 has a percent of 99.3, because that's what x was. That was the percentage of nitrogen 14. Well, since percentages always add up to be 100, we can find the percent of nitrogen 15 by saying 100 minus that. So nitrogen 15 ends up being the other 0.7%. All right, now let's see if this makes sense. Well, if the average is 14.007, then the higher percent is going to have to be closer to 14. So my nitrogen 14 should have a very high percent, since the weighted average is very close to 14. It's almost spot on, so it's almost 100%. And then the nitrogen 15 would have a very low percent. All right, make sure that you try the Google form to see how well you're doing with this.